So this section 9.1 is on what is called the composition of two functions. So remember the last class, what we talked about is we were given two functions, usually an f of x and a g of x, and then it would ask us to either add them together, subtract them, multiply them, or put one function over the other, and then talk about the domain, okay? What this section is it's kind of like it's putting one function into the other function, and it's called composing functions, okay? So let's look at number 1. F of x equals x minus 1. G of x equals x squared minus 5. Okay, and the way that composition of functions look is we're going to find f of g of negative 2. Okay, it looks like it says fog, but that little that says f of g, and I wanted to make it a little bigger like that so you distinguish it between, it's not a multiplication symbol, right? It's not to multiply. So the way you solve these is whatever is in this position is what you're finding first, because sometimes it'll say f of g, sometimes it'll say g of f. So no matter what it is, whatever is in right here is what you're doing first. So I am finding g of negative 2 first. Just like always, what does that mean you're going to do? You're going to go over to your g function and replace its x with what's in the parentheses. So in this case, negative 2. So if I do this here, I'll have negative 2 squared minus 5. Well, negative 2 squared is positive 4 minus 5 gives me negative 1. So you'll find what's in this position first, get an answer, plug that answer into the other. So in other words, you're just kind of bring this f down, and you're finding f of what your last answer was. So in this case, negative 1. And just like always, what does this mean you're doing now? You're going to your f function and replacing its x with negative 1. So if I do that, I have negative 1 in place of the x minus 1. That's not 0. What is that? What is negative 1 minus 1?
Negative 2.
Good. Negative 2 is your final answer. So again, the steps when you're doing composition is whatever is in that position, you find first. So I'm just bringing that down and finding g of negative 2 by going to my g function, replacing its x with negative 2. So I had negative 2 squared minus 5. Negative 2 squared is 4 minus 5. So that gave me negative 1. Which tells me what I plug into the other function. So in other words, now you're bringing down f, and you're finding f of what that last answer was. Which means go to f now and replace its x with negative 1. Okay? Number 2. F of x is 3x plus 4. G of x is x squared minus 2x minus 5. Okay, so remember last time we did f of g. This time it says g of f of 7. which means in this case, I find what's in this position first. This time it's F. So I'm finding F of 7, which means I'll go to my F function, replace its X with a 7. So in other words, I have 3 times 7 plus 4. Right. So 3 times 7 gives me 21, plus 4 gives me 25. And remember, that's just half of it. Now, where am I going? Whatever this letter is comes down. And what are you finding G of this time? 25. 25, your last answer. Which means come to G and replace its X's with 25s. So if I do that, I'll have 25 squared minus 2 times 25 minus 5. Right, so 25 squared is 625 minus 50 minus 5. So that would be 625 minus 50 is 575 minus 5, which gives me 570.
I have always been so bad at these, but you just made so many things like in my
You know why?
brain.
It's because I was bad at these. I had to, like when I took college algebra a long time ago, these confused me so much, and I don't know why. But, so I had to like break it down for me to be able to understand
Just
it.
the simple concept of like whatever is like whichever function is next to the actual number that you're substituting in. Yeah, so that just made so much sense out of everything I've been doing wrong. I'm getting with it.
So number 3, f of x is 3x plus 2. G of x is x to the 3rd. And we are finding f of g of -4. So again, that's what you're finding first. So G of -4. So I'm going to G, replacing its x with -4. So -4 to the 3rd gives me -64. If what you're cubing is negative, then yeah. Yeah, if this is negative and that's odd, then yeah, it'll stay negative. Dropping down the F. What was your last answer? -64. So that's what you're going to put in the F answer. I mean F function. So 3 times -64 plus 2. So -192 plus 2. -190. Okay, now we're going to be moving to doing the same exact process, except this is going to be an X. Okay, the steps are exactly going to be the same. You always find what's here first, get an answer, plug that answer into the other function, and solve that math. Okay, so, and now since this is going to end up being, since you're finding f of g of x, it's going to ask you about the domain. And it's going to ask you to put the domain in what's called interval notation. So before we get into number 4, let's see what interval notation is. Now remember, when we are finding the domain, what we're looking for is a restriction, right? So if there's a restriction, that's the number you want to leave out of the domain. But if there's not a restriction, we have just been calling it, right? That means X is all the numbers on the number line. The way you write that in interval notation, here's your number line, 0 in the middle. Your negatives go this way for eternity, forever and ever and ever, right? The number line never stops. That's called going all the way to negative infinity. That if sideways 8 is an infinity. My positive numbers go forever this way, which means where are they going to?
Positive infinity.
Positive infinity. So if there's not any restrictions in your domain, that means you want to include all the numbers on the number line from negative infinity to positive infinity. So the way you would write that is infinities always have parentheses around them, always. From negative infinity to positive infinity. These two things mean the same thing. No restrictions in your domain, all the numbers. Right, right. So if your answer ends up not having a fraction with an X in the bottom, then that's what it would, then you don't have any restrictions. Okay, but what if you do have a restriction? Let's say X is a real number, but let's say your answer ended up like that. You would have a restriction in your domain, right? Because what can X not equal? Right, that denominator can't equal 0. Which means X in this situation couldn't equal 4. So let's see what that would look like. Again, we haven't started working a problem yet. I'm just showing you how this translates into interval notation. Okay, we were saying X is a real number and X can't equal 4. If this was what we were talking about the domain of. This way, let's see, where is 4 on the number line? Right there. So I want to say all the numbers on the number line except 4, right? 4 is what needs to be left out of my domain. So let's see, I would start at negative infinity. All these numbers are good. So what you want to leave out is the 4, and then you put a parenthesis around that 4. That means not including that 4. So all the numbers below 4 is represented here. So that means all of this. What else do I need to represent?
4 to positive infinity.
Right, all the numbers above 4. So the only number that I want to leave out is 4. So the symbol that they use is this U, and it means in union with, or in other words, and. So from negative infinity to 4, and 4 to positive infinity. So that is how we do interval notation. So I always like to see the number on the number line that I'm trying to omit, which is 4. Which means include all the numbers below it and all the numbers above it. Okay, now let's work one like number 4. F of X is X plus 25. G of X is X minus 25. And I'm finding F of G of X. And I'm going to find it the other way around, but let's do this one first. Just like the previous 3 problems, this is what you find first, G of X. Well, here's g of x right here. I don't even have to plug anything in, because what does this mean you're doing? You're going to g, replacing its x with an x, which means nothing changes, right? G of x is x minus 25, right? It told me that in the problem. So that's as far as I can go with that, right? Because I can't put those together. So now I go to the next step, which means bring down the f. And what are you finding f of? Your last answer, which is x minus 25. So what do I do with this? I go to my f function. In place of x, you write all that. So in place of x, I write x minus 25. And then plus 25. And what happens to the minus 25 plus 25?
Cancel.
They cancel. So you are just left with x. That's your final answer. Then it wants us to find it the other way around. Instead of f of g, it wants us to find g of f of x. So this time I find f of x first. Go ahead.
Can you do the box one first one more time?
Yeah. So when I got, the first thing I found was g of x. So I just pretty much just went up here and said, that's what that is, x minus 25, which means now I am putting that, whatever that last answer was, comes in the parentheses. So I'm going to my f function. There's the x. Instead of x, I put in what was in this parenthesis. So x minus 25, then brought down to plus 25. But if you have minus 25 and plus 25, that's just 0 because they cancel. Because negative 25 plus 25 is 0. So that's why all you're left with is x. The same kind of thing is about to happen again here. Because this time, what am I finding first? F of x. And what is f of x? Right, x plus 25. So done with that part. Bringing down the g. What was your last answer? X plus 25. So I'm going to go to g, which is right here. What am I going to put in place of that x? What's in your parentheses? X plus 25. Right. So after x, which I replace with x plus 25, then I have minus 25, just like the last one. 25 minus 25 is 0. So that one also ended up just being x. Now it's going to ask you for the domain of each of these. So let's look at the domain. And remember, what are you always concerned about when you're talking about the domain? Restrictions. The only restriction that we've really talked about so far is an x in the denominator. So there's two places you have to look for restrictions. Your final answer. Is there a denominator? No, then I don't have to worry about restrictions there. All real numbers. You also have to look here to what you plug in. These two places are where you're looking for restrictions. Does this one have any? No. So all real numbers, all the numbers on the number line, it's going to ask for it in interval notation. And what is it if there's no restrictions? Negative infinity to positive. Good. These little infinity symbols, once you click in your answer box, they'll be down in your toolbox. Same thing here. What's this one's domain? Here and here is where you're looking for restrictions. Same thing. Number 5. F of x is x plus 4. G of x is 2x squared minus 7x minus 4. Doing f of g of x and its domain first. So what am I finding first? G of x. What is g of x? All this. 2x squared minus 7x minus 4. That's as far as I can take that, right? Nothing can combine there. So I'm dropping down my f. And what are you finding f of? Your answer from here. So in parentheses, I'll have 2x squared minus 7x minus 4. Which means where am I going? F. What am I putting instead of that x? All this. So I'm going to have all of this in place of here, then what's going to come after it? Plus 4. So 2x squared minus 7x minus 4, and then the plus 4. What do I combine? I can combine these, and what happens to them? They just cancel. So all you're left with is 2x squared minus 7x, and that's it. So that's your final answer for that one. Okay, let's go ahead and do its domain. And then we'll do it the other way. So where do you look for the restrictions? Your final answer and what you plugged in to get your final answer. Those two spots are where you're looking for restrictions. Do either one of these have any? No. So the domain is negative infinity to positive infinity. So now we're going to do all the same thing for g of f. It's going to take a little more work. So this time, what am I finding first? Right. F of x. And what is f of x?
X plus 4.
X plus 4. Dropping down g. And what are you finding g of? What was your last answer? X plus 4. Now here's where it gets a little more complicated. So where am I going? I'm going to G. What am I putting in place of those two x's?
X plus 4.
Right. So let's write that out and see what it looks like. So I have 2, then in parentheses, x plus 4, what? Squared minus 7, parentheses, x plus 4. Minus 4. Now, I'm going to do, because this is what I have to do first, because it has an exponent. So x plus 4 squared, I will do right here. I'm trying to stay in the. X plus 4 squared means x plus 4 times itself. Right? That's what you do when you square something is you multiply it times itself. So I'm going to have to FOIL here. So x times x. X times 4 is 4x. On the inside, I have another 4 times x, which is 4x. And then my last 4 times 4, 16. What can go together? Right. So I have x squared plus 8x's plus 16. So all I'm going to do on this next step is rewrite what I have left right here, but with this part worked out. Yeah. So 2, then x plus 4 squared ended up being x squared plus 8x plus 16. I'm just going to write all that. I'm just going to bring all this down. Minus 7 times x plus 4 minus 4. Now, how do you get rid of these parentheses? Distribute the 2 here and the negative 7 there. So let's see. 2 x squared. 2 times 8 will give me plus 16x. 2 times 16 gives me plus 32. Now distribute this negative 7 to remove these parentheses. So negative 7 times x is negative 7x. Negative 7 times 4 is negative 28. Drop down the minus 4 and then combine your like terms. So no other x squared. So I just have x squared, 2x squared. Let's see, I can combine this x. Good, so I'm left with 9x, that had 16 minus 7. $32 minus 28 is 4, right? Because then you have a minus 4 there. So you don't have any numbers left, no constants. So all you're left with is 2x squared plus 9x. And what's its domain? Where am I looking? Final answer. And what you plugged in to get the final answer. Are there any restrictions in either of these spots?
No.
No. So your domain, again, is negative infinity to positive infinity. You always look at your complete final ending answer, and then what you plugged in the last time to get that final answer. You're looking for restrictions in either of those spots.
So if you have a restriction in what you plugged in,
Yeah.
to get your final answer,
That's
set that
you leave that out of your domain. Yeah, and that'll happen on here, number 6.
Okay.
All right, last one. F of x is 5 over 1 minus 4x. G of x is 1 over x. So when you're looking at those functions, this is telling you there's probably going to be a good chance of having restrictions because you've got restrictions in the actual functions. First things first, finding f of g of x. All right, I'm just going to follow the same steps. We're going to have some different kind of math when we're simplifying these, but it's all the same steps, which means what am I finding first? G of x. Which means what is g of x? 1 over x. That's as far as I can take that. That just is g of x. Which means drop down your f. What was your last answer? So that's what I'm finding f of, 1 over x. So that's what I'm plugging in to get my final answer. So that right there is going to give me a restriction in my domain. We'll talk about the domain at the end, but that right there is why you have a restriction. Okay, so let's see what f of 1 over x is. So here's where you're going to replace. This is what makes this one complicated. It's the last one, and this is why we're not going any further. So I have 5 over 1 minus 4. What am I putting in place of this x? 1 over x. Okay. 5 over 1 minus. So I'm multiplying that 4 times 1 over x. The good thing about multiplying when you're dealing with fractions is you just go straight across on top and bottom. You don't care about a common denominator or any of that. That's only when you're adding and subtracting. So think about the denominator, think about that being 4 over 1 right there. So if I multiply in top, what am I going to have? Minus 4 times 1 is 4 in top. 1 times x is x in the bottom. Now, math lab and math in general is not going to let you leave that fraction like it is. It's too complicated, the fraction is. Okay? So what you're going to do is uncomplicate it. So the way I'm going to do that is because the reason it's too complicated is because you have a fraction within your fraction. Okay, so the way you fix that is you go to the fraction that's within the fraction, and you're going to multiply the top and the bottom of the whole fraction by whatever this is. So I'm multiplying the top and the bottom by x. Now, what's the rule that said, I mean, I can't just come and just start multiplying random things without changing stuff. But why do I do it on top and bottom? Because what is x over x? Or what is the fraction equal to if you have the same thing in the top and the bottom? It's always equal to 1. Doesn't matter what it is. If it's the same in the top and the bottom, it's 1. So I am essentially just multiplying this whole fraction times 1. If you multiply things times 1, do they change? No. Doesn't matter what it is. So I'm not changing the amount of this fraction because I'm just multiplying it times 1. The one that you use to help you uncomplicate this answer is always whatever this denominator is. Because now look what's going to happen. Up top, I've got 5 times x, 5x. This x goes to both of these down here. I distribute it. What's x times 1? X minus, look what happens here. What if you have an x in the top and the bottom? What are they going to do? Cancel. That's why you use this to do this process, because you're trying to cancel the x in the denominator. So now, since those x's cancel, I just have x minus 4 as the denominator of my final answer. So that's your final answer. Domain. I got restrictions. I look at my final answer. So this denominator can't equal 0. So x minus 4 can't equal 0. And where else do I look for a restriction? Where you plugged in to get to your final answer. So this also has an x in its denominator. So you say this denominator can't equal 0. So that one's already solved. How do I get this x by itself? Add 4. So x can't equal 4. So it can't equal 0, because if it equaled 0 and you put a 0 here, you wouldn't be able to plug that in because it's undefined. Okay. Also, you can't use 4 because that makes that undefined. So I want to show that in interval notation. If I have multiple restrictions, I like to see what it looks like on a number line first. So put your restrictions on the number line. And the domain on this one is actually multiple choice, so you're not gonna have to type all this in. So I want to talk about negative infinity to positive infinity, but leaving out 0 and 4. So what represents all the numbers below 0, which is what I want to include. So where does that go from?
Negative infinity to 0.
Negative infinity to 0.
And then union,
You.
0 to 4.
Good, because you do want to include this part, right? All the numbers between 0 and 4 are good. So 0 to 4.
And then 4.
And then
union,
the
4
last
to
chunk, which is all the numbers above the 4. So from 4 to infinity. And again, that part of the problem will be multiple choice. You're not going to have to type all that domain out.
So also with the 0 and 4, it has to be parentheses because you don't include.
Because you don't
right?
include them. Including symbols are brackets.
Okay.
Yeah. And infinities are always parentheses because it just means it got, you're going all the way forever. So there's half of that problem. Because what did we just find? F of G.
Oh, no, I didn't do
This is
that.
the last thing. And we're getting out 10 minutes early. What am I going to find now? G of F
of X.
of X.
Oh my god. This took up a third of the page just for this one.
This. Yeah. So that was the answer. And then that was the domain. Go ahead.
So as many, you can have as many of them in parentheses as long as you put the U between, right?
Yep.
As many as
Yep.
it takes, okay.
Yep.
Yeah, I can't think of the word.
Restriction.
Restriction.
Got you.
So now I'm going G of F. Same steps. This is the last one. What am I finding first?
G-O.
F of X.
Didn't we just do that one though?
No, we did fog. Right? F of G. Now we're doing fog.
Okay. Oh,
So
yeah,
what's
yeah, yeah.
first? F of X. What is F of X? 5 over 1 minus 4X. So I'm done with that. So now what am I finding? G of, good, 5 over 1 minus 4X, which means I'm going to go to G. Instead of this X in your denominator, what are you going to put in place of that X? All this. So I've got 1 over, replacing the X with what's in parentheses. So I have 5 over 1 minus 4X. So again, I've got too complicated of a fraction. On the last one, remember the denominator that I was trying to cancel? What was it? X. That's what I used on top and bottom. What's this one's denominator that I'm trying to cancel?
1 minus 4X.
That's what you're going to use on top and bottom. That's what you're trying to get rid of. So I'm using 1 minus 4X in top and bottom. So up top, I've got 1 times all that, multiplying it times 1, so it's just not going to change. 1 minus 4X. And here's why we use this, because what's going to happen in the bottom with these two things?
They cancel.
They cancel. So what are you left with?
5.
5. That's it. That's the final answer on that, because the 1 minus 4X is canceled, which means I just had the 5. Domain. Look at this, does have a fraction, but what do you not have in the denominator that gives you the restrictions? There's no X down there. So this final answer actually doesn't have any restrictions in that part. But
It's what you put in.
here's
right?
what I put in. Does it have an x in its denominator?
Yes.
Yeah. So what can 1 minus 4x not equal? Can't equal 0. Solve it for x. So subtract the 1 from both sides. So negative 4x can't equal negative 1 and divide by negative 4s. So x can't equal the negative over the negative makes it positive 1/4. That's my only restriction. So from negative infinity to positive infinity, except for 1/4. So all the numbers below 1/4. So negative infinity to 1/4. And all the numbers above 1/4, which would be 1/4 to positive infinity. Okay?